Over the third technology assignment. It's called Trig equations. So I'm just going to click open the file. So the guided example, you could do all this on Desmos. The guided example is, I tried to make it as straightforward as possible, but it basically tells us to put in this equation but in a particular way. All right, so let me go to Desmos. We're going to type in y equals whatever the left-hand side, over highlighted there. Given the equation, whatever the left-hand side is, we're going to type that in as y equals, and then we'll type in whatever the right-hand side in as y equals. So y equals, I already forgot, 2 sine squared x. 2 sine, hit shift 6 if you're using a keyboard. There's a little shortcut to get you to the power of 2. X, and then y equals cosine of x. All right. Now what we want to do is restrict these graphs to the appropriate domain. This one's going from 0 to 2 pi. So I only want to go from 0 to 2 pi for each piece of this equation, the left side and the right side. So what I do is, using inequality notation, is I'll type in 0 is less than or equal. If you do the less than symbol, so shift comma, followed immediately by an equal sign, that's a nice keyboard shortcut for less than or equal. Otherwise, you go into this Desmos keyboard and just pull it up from there. All right. X less than or equal to 2 pi. All right, just type in pi and it'll change it to 2 pi. All right, so again, 0 to 2 pi, the brackets include the value, so that's why it's less than or equal. Then you could just do a copy paste and put it in for the other piece also. Then you don't always have to zoom, but I prefer to. All right, get a nice view of the graph. Any intersections that you see would be solutions to the problem. We only care about the x values because if you look at your equation, you see it's 2 sine squared x equals cosine of x. There's no y in there. We introduced the y. So we only care about what the x values are. All right, so what we would do is identify those coordinates. You tap on its 0.675, comma, 0.781. But you see when I click on it and then click elsewhere, it goes away. So click on it, take note of what that point is, and then type it in. So 0.675, comma, 0.781. All right. So what I would do, because the point is labeled right here, I would just write solution. All right, we got another one over here. 5.608 and then 0.781 again. So for that, a little copy paste goes a long way. So again, it was 5.608. So I hit the wrong thing, 5.608. This is also a solution. All right. You don't need the numbers to show up on the graph because they're off on the side here. All right, so we know what the solutions are. If you want to say specifically that x, x is equal to 0.675, you could say in quotes, x is equal to 0.675, and then do the same thing, open quotes, 5.608. It might make it a little nicer to look at. Either way, you have your x equals on the appropriate domain. So this is giving an indication of how you knew what those x values were. Right? And that's all you really need to do in order to come up with a nice Desmos solution for a trigonometric equation. Right? It's decimal values, so you're not going to get simplest radical format of this, but if you need to get a nice approximation of what the solutions are, this is a good approach. All right? So that takes you through all this. You can see the whole guided example just kind of boils this down for you. It is possible to have no solution, meaning the two curves don't cross at all over the interval that you're given. And it's possible to have infinitely many solutions. So for example, if I told you, I don't know, I'll give you a simple case. I'll open a new Desmos so I don't wipe all that out. Graph and calculator. Let's say we have y equals cosine of x, and then y equals sine of pi over 2 minus x. All right, looking at these two graphs, I'll turn them both off. You see they're the exact same graph. All right, you can make it more obvious if you long press on one of them and change the thickness. I like to make one dashed and the other not. All right, so it kind of sticks out a little bit more. All right, so, well, it doesn't really stick out that way. I did it backwards. So make this the 5. The dash one should be the thicker one. Otherwise it defeats the purpose. But so you can see here that they're the same graph, which means that every point coincides. So it isn't just a matter of finding one intersection. They're all intersections. Every part of each graph intersects with every part of the other graph. All right, so that could happen sometimes. So you just got to be on the lookout for that. All right, you see these examples here. The first one is the same problem but a different domain. All right, second, third, fourth, they're all different problems. But then what I did was I created a random problem generator. If you go into the technology assignment, you'll see Desmos Trig equation randomizer. So you'll come to this link, and then you'll just have to click on continue to the activity, assuming that you're logged into Desmos. If not, you'll create an account or log in. You should all have accounts by this point, though. So generate a new problem if you don't like the first one that you see there, but if this one's fine, then just go for it. But you know, I'm just going to go down the line a little bit and grab something funky. All right, so what I'm going to do, just so everything matches up for consistency, was just do a Command-Shift-4, well, or snippet if you're using a PC. Take a screenshot of it. And then I'm going to open a Desmos, and I'm going to put my screenshot as an image into the Desmos. Now, if you click on the image, you could drag it wherever you want, kind of get it out of the way. I mean, I'm doing this for a couple reasons. The obvious one is so that I don't have to flip back and forth between the pages, but the other one is so that you as a student can tell me as the grader, G-R-A-D-E-R, what problem you were working on, so I know how to assess you, right, or assess your performance. So I'm going to type in y equals -1. So this one's on me. A freebie for you. Y equals, so don't do this one. Cosecant. We have 5x plus 2 raised to the 7th power. That's a crispy looking function right there. But we want to restrict the domain from -2 pi to pi. So open the squigglies. -2 pi less than or equal to x less than or equal to pi. All right, -2 pi to pi. And then I'll also restrict my y equals -1 equation with that same set of boundaries. All right, we don't need this top stuff, but we also don't need to get rid of it. So what I'll do is I'll just move this down here and slide this on up. Each one of these corresponds to a solution. All right, so I mean it's a little bit of typing, but I'll just need to get all this onto Desmos. So I'm just going to do another screen grab so that I don't have to worry about, because you click outside of that, you take all the time to click on these things, and then you click anywhere else and it goes away immediately. So I'm going to put this image in there. Just kind of chuck it in over here. So I have a nice looking set of solutions, but I also want to get the coordinates plotted. All right, so that's the tedious part. So negative 5.741, comma, negative 1. Fortunately, all the y values are negative 1 here, so I'm going to see if I can get a little cute with this and at least copy that part. All right, so that's a solution. Negative 4.484, comma, oh, the comma is already copied in. Click on that label. And negative 3.227. Negative 1.971. Negative 0.714. Just want to make sure every solution, that's why I keep hitting label. I want to make sure every solution is accounted for. All right, 0.542. $1.799. And 3.056. Now these are all the coordinates of the intersection. So we could say solutions, we could say intersections. For the previous examples, I think I wrote solutions, but really that's fine. If you want to label this up. Because we have the values on the side, maybe not plural. All right, and so then I would just want to state what my final answer is. So x would be equal to negative 5.741, negative 4.484. So very tedious, but I promise you it's a whole lot more straightforward than having to do this by hand. All right. Actually, for this problem, that one could be debated, but in general. 0.971, negative 0.714, 0.542, 1.799, 3.057. All right. And so what I would say is, just to make it completely obvious and no doubt about it, these are the answers to the problem, if you want. Answers, solutions. Well, the whole thing's a solution, so you could just say the values of x that satisfy the equation, or you could just say answers, like I said. All right, but this would be something ready-made to be submitted. You could leave this there or not. It doesn't make a difference to me. It's really more about this stuff. All right, so all these bits and pieces. So all the images that you put in are just kind of immaterial. It's really more about the visual aside from that, right? And all the scripting stuff on the side, right? And so there you go. All right, so you create your share links with the little arrow jammy there, share it, copy this, put it into Blackboard, and you get credit for this part of the assignment.